pleasure to introduce an old friend, Jim Ammerman. Jim is currently the science coordinator for the U.S. EPA Long Island Sound Study, and prior to that, he was right here in our workspaces, and he was the director of the New York State Sea Grant program. Jim got his PhD in marine biology in 1983 from the University of California at San Diego, but he's had a variety of posts since graduating, and besides being the director of the Sea Grant program, he was science director of the NOAA Undersea Research Center at Rutgers for a number of years. He was also associate research professor at the Institute of Marine and Coastal Sciences at Rutgers. And he got his start very early in his career at Lamont Doherty and then moved on to Texas A&M before coming over here to New York. So Jim, welcome back, and you're going to talk today you have a very intriguing title, Global Coastal Eutrophication from the Lorax to Long Island Sound. So that will keep me awake.
You also mentioned that Jim's an adjunct faculty member.
Yes, and Jim is an adjunct faculty, right here at Stony Brook.
Yeah.
In SoMAS.
Leave the back one on. Yeah. How's that for everyone? Yeah. Okay. Thanks a lot, Larry, for that introduction. And I did try to make an intriguing title to keep you awake, and I will glance over there to make sure you are. Okay, I know. Okay, so this is what western Lake Erie looks like these days in the summer. This is a boat wake in Lake Erie, which has gone back to the 60s, and I'll talk about that. Okay, from the Lorax, which probably many of the students here grew up with this book. And if anyone knows its connection to my topic, I'll give you a chance at the end to bring that up. To Long Island Sound, and as Larry said, I'm the science coordinator. This is a very high up view of Long Island Sound, and my whole talk will be kind of a 30,000-foot view of the issue of coastal eutrophication. There are lots of acronyms and things in this, since a lot of it's policy related. I'll try to define them as I go along, but if I miss one that you don't understand, please bring it up. I apologize for my voice. I had one of those early summer colds, which I'm still coughing from. It just takes a while. I've even been to a doctor. So, okay, so let's get started. So this is my official title. I'm part of the New England Interstate Water Pollution Control Commission, which is headquartered in Lowell, Massachusetts, but I'm actually located at the program office of the Long Island Sound Study in Stamford, Connecticut. Larry mentioned some of my experience. This summarizes it. I won't go into details. Just I've had one of those careers that they say is going to be the careers of the future, where you move to new jobs every few years. Well, that's been me. This doesn't even include the 3 places I was a grad student at. So I've moved around. Okay, the synopsis of what I want to go through today. The concept of planetary boundaries, some of you may be familiar with. The nitrogen-phosphorus debate in the literature. Various national assessments of coastal eutrophication. System comparisons, and I'm going to go into a little bit of detail in 3 different systems that I've been involved with. The Gulf of Mexico, Lake Erie, and Long Island Sound, of course. And then I'm going to make some comparisons and conclusions. And these 3 examples are just 3 different types of a problem that's, as you will see soon, is global. Okay, so some of you may have heard of the Stockholm Resilience Center. It's a group of scientists and policy people in Sweden who've published a number of papers on the subject, including high-profile journals like Science. They have a concept called planetary boundaries. And to get my eutrophication green dot up here, they would argue that in 4 of these, if you consider this line right here, safety zone, this thick line, in genetic diversity, climate change, land system change, and most importantly, biochemical flows of phosphorus and nitrogen, we've already exceeded the safe limit. And of course, they have nitrogen and phosphorus almost being to extreme issues, well ahead of the current impacts of climate change. And so, but this is an issue that most people don't think of as a global concern. They're worried about their backyard lake or pond or estuary. But people all over the world are having the same problem. And the issue, of course, is nutrient runoff of various types, from wastewater treatment plants, agriculture, urban, septic systems, excess nitrogen and phosphorus leading to algal blooms, hypoxia, etc. This is all well known to you, and obviously Long Island and Suffolk County are now making major efforts to deal with the issue of excess nitrogen in our local embayments. Thanks largely to some of the scientists here. There's a lot of action in this area, but this is not limited to Suffolk County by any means. It's found all over the world. This is a global map of hypoxic sites around the world from a paper by Nancy Rabelais and others. There's 480 sites here, all the red dots, and this is of a total of 800 eutrophic sites, coastal eutrophic sites. So there were another 300 that were eutrophic but not hypoxic. There have been a few examples of improvements in systems, Tampa Bay being one. The northwest shelf of the Black Sea, which, not the anoxic part, but the shelf above that was going eutrophic in the 80s when the Soviet Union and Eastern European economies collapsed. The fertilizer stopped and the shelf returned to health, but now I understand it may be going the other way again. So this is a problem all around the globe, particularly, of course, in the developed countries, but also increasingly so in the developing world. I'll acknowledge Chris Gobler and his student Matt Hark for this recent review. I'm going to talk mostly about marine coasts, but this is a map of Microcystis, the cyanobacterial harmful algal bloom, which is toxic, and its occurrence, the bloom, and toxin, or just the bloom, you see it's a global issue. And I'll be talking about this in detail for Lake Erie. Okay, I mentioned the nitrogen versus phosphorus debate. This has been going on for a while. Many of you may know of David Schindler, who was a famous limnologist, best known for his multi-decade nutrient experiments in the experimental lakes area of Canada, where they doused entire lakes with nitrogen or phosphorus, both, and monitored them for decades. It's a kind of experiment you can't do in a marine or estuarine system. And he's concluded from these kind of experiments that phosphorus rules all. And in lakes, perhaps that's the case. But his paper here even hinted that maybe estuaries were actually phosphorus limited, not nitrogen. And that, of course, raised a ruckus. So there was a follow-up paper to that a year later called Controlling Eutrophication, Nitrogen and Phosphorus by a distinguished group of marine scientists. And I actually reviewed this paper before it was published. And they've sometimes been known as Schindler's List, if you recall the movie. So, but recently, partly as a result of this, and some of the work we did in the past and others, the US EPA and the European Union have actually adopted dual nutrient criteria. Means for most of the systems they worry about, they're concerned with both nitrogen and phosphorus. And so this was a document that came out last year supporting this, but David Schindler's still hard at work and has recently, last month, came back with a new paper, Environmental Science and Technology. And this was actually from the paper, the front page of the opening page of the paper. He's got nitrogen control as a house of cards in lakes. And all these successfully cleaned up lakes based on phosphorus alone. So he's not content yet to consider the dual nutrients. And he argues that basically any kind of bottle incubations or anything short of a whole lake is invalid. So, but how do you do that in marine systems? Anyway, so it's an ongoing discussion, clearly. Okay. Now, coastal eutrophication is the subject of a number of national assessments, and I can go into the gory details of this later on. I don't have time right now. The EPA does a national coastal condition assessment every 5 years. The latest one published just this year is data from 2010. They do a standard set of measurements all around the country, including now the Great Lakes. And it's more than just water quality. It's also sediment quality and toxics and a whole bunch of things. NOAA does its own assessments periodically. These are a little more, I would say, thorough and more specific for each estuary, but they don't occur on a regular basis. They've also, some of this has been done with a group called IAN at the University of Maryland, which is Bill Dennison's group that looks at application of science to policy issues. And this group also develops report cards of water quality for Chesapeake Bay, for places all around the world. They've done one recently for Long Island Sound, as well as a couple of the embayments. And I can talk about this at the end if anyone's interested. Okay, so these are the three systems I'm going to address. As I mentioned, the Gulf of Mexico, which is the second largest fish landings in the US, and globally it's the second largest dead zone following the Baltic. Lake Erie, which is drinking water for 11 million people, and Long Island Sound, which from my perspective is an underappreciated estuary, which has really, it's America's urban estuary with 23 million people living within 50 miles. It's our backyard estuary here. So I did 20 years of work on the Gulf of Mexico. I also addressed about a decade ago, the EPA has a science advisory board, and they convene special panels for certain issues. And one of those is Gulf of Mexico hypoxia. So I addressed them 10 years ago, and it had a major impact on the report they put out subsequently. When I was Sea Grant Director, I got involved with Lake Erie because, believe it or not, Lake Erie is, some of it's in New York, so it's part of Sea Grant's area of interest. And most recently, I've been on an actual EPA Science Advisory Board panel that's evaluating the re-eutrophication of Lake Erie, specifically phosphorus loading models. And finally, I was also concerned with Long Island Sound as Sea Grant Director. I was on the management committee of the program, and now I coordinate the science for the program. So just a couple comparisons. You may not realize, note the surface area of Lake Erie is 7.5 times that of Long Island Sound. So we think of Long Island Sound as a big estuary. We have to go around it all the time. But Lake Erie is the second smallest of the Great Lakes, and yet it's 7 times the size. This is area of Gulf of Mexico. That's huge, of course, but about half of it is shelf. And the rest is deeper water. The watershed area of the Mississippi, again, is huge. It's the 3rd largest in the world. Drains about 40% of the U.S., continental U.S. Note that Lake Erie and Long Island Sound have kind of comparable watershed sizes, only about a factor of 2 between them. Depths of Lake Erie and Long Island Sound are comparable, average. And like I said, I'm going to talk about them in more detail, but the primary nutrient is different in each case. In Gulf of Mexico, nitrogen is the big problem. So there is evidence for P limitation as well in the spring. Both of them come from agriculture, predominantly. In Lake Erie, it's phosphorus again from agriculture, although there's increased interest in nitrogen because it increases the toxicity of microcystis and has other impacts. And finally, Long Island Sound is clearly a nitrogen problem, largely from wastewater treatment plants, but not entirely. In some of these report cards and other assessments, phosphorus has shown up as an issue, but I think that's a mistake, clearly. So let's start with the Mississippi River watershed. This is the Mississippi River. It drains all the way from Idaho to New York State. It's enormous. It's about 40% of the U.S. And it all drains into a little area right down here where the hypoxia is. So if we look at the coastal hypoxia, again, the watershed, this is the area down here shown along here. This was the 2015 Gulf of Mexico dead zone. Their limit for hypoxia is 2 milligrams dissolved oxygen per liter. It's different from Long Island Sound, I'll point that out. Was almost 17,000 square kilometers, and this is larger than the state of Connecticut and Rhode Island put together. Now, it's the red area here is the lesson 2. This survey is always done at the end of July, 1 survey a year. I should have one from 2016, but unfortunately the 2016 survey was canceled. There will be no survey this year for the first time in 27 years. In the past, they've used various academic research vessels, typically the Pelican from Lumcon. In the last couple of years, they've switched to NOAA ships. And this year, the NOAA ship, the Nancy Foster, died from engine trouble. And nothing else was available, so no survey will be done this year, as far as I'm aware. Okay, so how do we deal with the Gulf of Mexico dead zone? Well, here's an acronym for you. Anyone know what HABARCA is? It's a law, an act of Congress. You're still awake, Larry? Good. It stands for something like Harmful Algal Bloom and Hypoxia Control Research Act, or something like that. It requires that the Hypoxia Task Force, which is a group of government officials, high-level officials, it's chaired by the EPA Assistant Administrator for Water. It has some other federals on it, and then it has state members all the way up and down the Mississippi Valley who are like agriculture and or environment commissioners or both. And they're the ones who set the targets for dealing with Gulf hypoxia. So, as I mentioned before, I testified to this panel in 2006. In 2007, they completed a major 300-page report. It's online. I recommend it, but it is kind of daunting. And this report recommended nitrogen and phosphorus reductions of 45% to reduce the hypoxic area to 5,000 square kilometers. Remember, last year it was like 17,000. Okay. Let's see, wrong button. Okay, so the Hypoxia Task Force approved this in the 2008 action plan to be achieved by 2015. Anyone think it happened? Okay, I'm seeing a lot of head shaking. Recently, the goal was postponed to 2035 with an interim goal of a 20% reduction by 2025. This was in last year's report to Congress. So what does hypoxia look like in the Gulf? Okay, this is the 5-year average right here. This is the goal. You see a lot of variability in this, correct? Particularly from 2000 on. Now, there's basically 2 reasons for this. 2000 and 2012 were drought years, very low flow years. Nutrient input was limited. Remember 2000 and 2012, we're going to look at that in the next slide. Other years that are low are typically because hurricanes or tropical storms came through, stirred up the water before they actually did the survey at the end of July. You remember this area around New Orleans is a major hurricane impact area, so that's the other major explanation. And you can see we're a ways from the goal here. So, okay, I don't know if you can see this. This is annual nitrogen flux and annual phosphorus flux. The point is, the 5-year average until recently has actually been going up. What actually determines these nutrients is usually how many acres of corn are planted in the Midwest. Depends on what's in the Farm Bill. It's non-point source input. It's not regulated. So if ethanol is a big deal, they plant more corn and you get more nutrients coming down the river. I will mention a significant fraction of the phosphorus in particular is also animal waste because they're concentrated in animal feeding operations. The one thing you might be able to see from the back is that 2012 and 2000 again are actually below the target for nitrogen, pretty low for phosphorus. Those are the drought years. And again, the hypoxia was low because the nutrients were low, because the flow was low. So you can see how important the river flow and physics are to this. Okay, any questions about the Gulf while I'm there? I'm going to come back to it in a comparison. But now I want to talk about Lake Erie. This is a freshwater lake. I admit it's not marine, but like I said, it does provide drinking water for 11 million people, so it's pretty important. You may recall in August of 2014, there was a big news story about Toledo, Ohio shutting down its water intakes. Everyone had to drink bottled water for a few days. That was part of this issue. Larry, you still awake? Yeah. Okay, so this shows the watershed of Lake Erie. Right here, all the bright green. It's only about twice the size of the Long Island Sound watershed, and also shows the total phosphorus loading. What you notice is the big arrows over here from the Detroit River, and particularly the Maumee River. This area over here is a big 3-state agricultural basin to the west of Lake Erie. It's Ohio, Michigan, and Indiana. A lot of row crop agriculture, some concentrated animal feeding, and one thing you may not be aware of in terms of row crop agriculture in the Midwest, which also applies to Gulf of Mexico and the Mississippi, is a lot of these fields are tile drained, which means it used to be wetlands, and they've built drainage systems underneath, and that swooshes the water with all the nitrogen and phosphorus, particularly the nitrogen, directly into the streams. And so that's also an issue. So you see the large phosphorus here. Okay, this is Lake Erie in September 2015, satellite. This is true color satellite. This is a microcystis bloom of a toxic cyanobacterium. It's typically, and here's the watershed again, and you remember this high phosphorus input over here. The Lake Erie is divided into 3 basins: Eastern Basin, Central Basin, Western Basin. Typically, the microcystis bloom is located in the Western Basin and stays pretty much there. 2015 was unusual, and that it got advected throughout much of the Central Basin as well. Toledo, Ohio is right here. This is where the water intakes were shut down. They have this bloom every year. In fact, you can subscribe on NOAA's website to a Lake Erie Harmful Algal Bloom Bulletin and get the weekly satellite pictures of what's happening in Lake Erie. So the microcystis is always here. It was unusual last year in that it was in the Central Basin. So, okay, so what happened to Lake Erie? It was our textbook fixed up lake. In the 60s, it was a disaster. You remember the Cuyahoga River caught on fire, all kinds of other issues. But we also had big nutrient problems, algal blooms and hypoxia. So the first Great Lakes Water Quality Agreement, of course, with Canada, Lake Erie has Canada on the north side, so it's a 2-country system. Total phosphorus loads were reduced to, this is metric tons per annum input by the early 80s, largely from improving wastewater treatment plants and detergent bans. So it was a textbook example of something that worked. And it showed it worked because water column phosphorus, plankton, phytoplankton, and hypoxia declined. And at that point, we said, oh, okay, it's fixed, and dropped the ball. The annual total phosphorus loading inventories that were compiled every year ended in '93. And after '93, the models ignored some major ecosystem changes. The Dreissenid mussels, quagga, and zebra mussels have upended the ecosystem in the Great Lakes in many cases. Clarified the water, probably made nutrients more available near the shore, and we dropped the ball. So what happened? By the mid-90s, there were developing problems with microcystis, particularly in the Western Basin. There was hypoxia in the Central Basin, and there was Cladophora blooms in the Eastern Basin. Lake Erie has its own specific problem to each of the 3 basins. We actually have Cladophora in some of the embayments of eastern Long Island Sound as well. It's a benthic green alga, attaches to hard surfaces, and then when it breaks loose, it piles up on the shore and rots in big piles. In Lake Erie, they call it beach muck, and there's huge piles of it in the eastern basin. So as I said before, I'm part of an EPA Science Advisory Board panel that's evaluating another 40% reduction in phosphorus and other strategies. We're also looking specifically at the importance of nitrogen. So what's happened? Okay, Lake Erie. This is the microcystis bloom severity from about 2000 till last year. So this is based on a severity index based on NOAA satellite data. And this is what you can get at the end of the year from the weekly update. Anyway, 2015 was the worst year ever. 2011 was a huge year a few years ago, but 2015, even though the forecast was only 8.7, actually hit a 10.5 on the scale, and I'll talk more about that later. So it was the worst year ever. And yet the total phosphorus has really not gone up. So what's going on? This is from a review by Don Scavia a couple years ago. What's important to notice first is the target, 11,000 metric tons per annum, would be right here. So you can see we're really not exceeding, once we lowered the phosphate to begin with, we're really not exceeding the target, with the exception for occasional annual changes. What's important to notice, if you look at the light blue here, this is the point sources. And this is what we fixed in the 70s. We actually decreased the point sources, and they've stayed low, even declined a little further. So what's happening here? Well, the main problem is the dark blue, purple, and the yellow, orange here. And those are non-point source inputs, such as from agriculture. And you see they are now much bigger than the point sources. So they're a major part of the phosphorus input. And what seems to have happened, and I apologize to those who can't see the bottom of this, but even though the total phosphorus has not increased, what has increased is the readily bioavailable phosphorus, which some limnologists would call dissolved reactive phosphorus, or DRP, and some oceanographers would call it soluble reactive phosphorus, or SRP, and the fraction of that is a fraction of the total. Now it's gone up. This is in 4 major river basins, including the Maumee, in some cases approaching almost 50% of the total phosphorus loading. The reason for this is not totally understood. Some of it may be increases in agriculture, perhaps also changes in agricultural practice, which has happened. No-till agriculture can be a great idea, but if the fertilizer goes on top and isn't mixed in, it could run off more quickly. So there are a number of possibilities for this, but the fact remains we have not exceeded the total target, and yet we still have a clearly worsening problem here. So, okay, so now to my last system, and I'll get back and compare all three at the end. Long Island Sound, our backyard estuary here. It's a bit unusual. It's oriented east-west. Most East Coast estuaries in the U.S. anyway, Narragansett, Delaware, Chesapeake are all north-south. It's connected to the ocean at both ends. That's a little strange. It gets about 70% of its fresh water from the Connecticut River, which comes out right here near the mouth. So, and it serves as a kind of a division between the mid-Atlantic down here and Gulf of Maine coastal ecosystems. So Long Island Sound's in the middle of everything. So the watershed is fairly large, although not much of it's on Long Island, and extends all the way to Canada, actually. So particularly the Connecticut River Basin has some significant agriculture input. So, but of course the big 800-pound gorilla is New York City over here. So this is what the hypoxic area looked like the middle of August this year. And I'll show a graph comparing different years in a minute. But the Connecticut Department of Energy and Environmental Protection does weekly or biweekly surveys. They've done it for like 27 years. And unlike the Gulf of Mexico, here we call something hypoxic if it's less than 3 rather than less than 2, which means it's an easier standard for hypoxia. And this year the area was 511 square kilometers. which is a significant impact, a significant increase from prior years, as I'll show you in a minute. I should also mention that the North Shore, of course, has some red tide blooms periodically, particularly around where I live, right here. But Chris, since the sewage treatment plant in Northport has been fixed up, those haven't come back, not in the intensity they were before, right? Right. Okay. So maybe it's an example of success, even though a small area. So Long Island Sound nitrogen reduction has been a concern for a while. You're still awake, Larry? Yeah, good. So there was a TMDL, total maximum daily load, approved in 2001, and largely nitrogen from wastewater treatment plants, and they've been reduced by 19 million kilograms per year since then. This is about 98% of the target reduction. The management documents all put this as 42 million pounds, but I translated it into science. So, there's been also some declines, though not so well understood in terms of ag inputs and atmospheric deposition over this time. The average hypoxic area has declined somewhat, but the duration of hypoxia is unchanged. That means how long it remains. EPA has a new nitrogen strategy, which I could talk to you about later, to look specifically at 3 watershed types and develop nitrogen thresholds for these different types. They include, and there's more of a focus now on embayments, not just the main stem of the sound, tributaries, and as well, still coastal wastewater treatment outfalls like New York City and other cities around the sound are a concern. And of course, New York and Connecticut also have nitrogen reduction efforts on Long Island. So Long Island Nitrogen Action Plan, which Suffolk County is very active in. And in Connecticut, they have something called the second generation nitrogen strategy. So this is become a major focus. And what does hypoxia look like in the Long Island Sound? Well, 2012 was a very warm year, and we hoped it was just an exception in this downward progression. But then this year happened, and boom. If you recall, August was hot and still, and so a lot of that is likely to be physics, but it went up, way back up. So our nice line going down. We could claim one exception, but it'd be tough to claim 2, I think. So, but there has been some decrease since the TMDL was agreed to in 2001. Okay, so I've gone through all these 3 systems. Now I want to make a few comparisons between them. Okay, one thing to note here, both the Gulf of Mexico and Lake Erie have models that have been developed to predict, in the Gulf of Mexico, to predict the area of hypoxia, and in Lake Erie to predict, the bloom intensity. And these were the predictions for 2015. The actual hypoxic area and blooms were 11 to 20% higher than predicted. And in both cases, it was actually due to the same cause. It was due to heavy June and July rainfall events and runoff from land. So, and most of the models have, in the past, have taken the nutrient input only as far as May. But clearly, June and July make a difference here. Okay, I mentioned the nutrients before. So what are the rules proposed? As I mentioned, in the Gulf, 45% reduction of N and P in Lake Erie, we're still discussing a 40% reduction of P beyond the previous target of 11,000 metric tons per annum. In Long Island Sound, we've achieved a reduction of 19 million kilograms, more than 50% of the total, but we still have clearly some issues. So we have further to go. So what do you say about the direction of this? The Gulf seems to be more or less steady, but it's variable. It obviously depends on the river flow, depends on the storms. Until a couple of years ago, the nutrients were actually going up. Maybe we could say now it's kind of steady. Lake Erie clearly seems to be perhaps worsening. Last year being the highest bloom index so far. Clearly this year they haven't finished the monitoring, but it's going to be less than last year because there's been a lot less rainfall and inflow. Long Island Sound, we like to think we were making significant improvements. This latest hypoxic number casts a bit of doubt on that, but I think there are some things improving. So I have a large set of conclusions here, and I'll go through them briefly. Nutrient reduction is expensive for point sources, particularly if you have to work with wastewater treatment plants. And I will point out nitrogen versus phosphorus is important because nitrogen is more expensive to remove. It's much more soluble. Phosphorus is typically on particles, easier to get rid of. And so, for instance, deciding to remove nitrogen for Lake Erie is an important question because it would be expensive. And maybe you could correct the problem just with phosphorus reductions. However, with non-point sources, we have another problem. And I mentioned this before. A lot of it is agriculture. It's not regulated by the Clean Water Act. EPA can go to a city and say, you have to improve your wastewater treatment plant nitrogen removal. They can't go to Iowa farmers and say, you have to reduce your fertilizer inputs by 50%, because there's no basis in law to do that. And so non-point source reductions rely on incentives, cajoling, etc., to improve conservation practices, etc. And as I mentioned, varies with the farm bill, whether the corn price is good this year, so you plant more, etc. A big issue in many of these environments that we don't understand very well are legacy nutrients in the sediment, because in the case of, at least with fertilizer and wastewater treatment, we've been loading many of these systems for 50 years at least, and often longer. And so they have nutrients in the sediments. There's limited evidence that the Gulf of Mexico may be getting even more nitrogen sensitive. It could be from sediments. Weather, particularly major events like floods and droughts, have significant impacts, as we've seen, both in the Gulf and Lake Erie last year, in Long Island Sound this year with the hot weather. Continuous monitoring is required to keep an eye on what's going on. Improvements can easily be reversed. We dropped the ball in Lake Erie and see what happened. And finally, climate change kind of hangs over all of this, because you have obviously increases in water temperature and acidification, but also has major impacts on almost all aspects of the water cycle: precipitation, runoff, stratification, everything you can name. And many of these things, though not all, are likely to increase the impact of eutrophication. So we can reduce a whole lot of nitrogen, but if the temperature warms up, the stratification increases, you may still not get rid of the hypoxia. So that's a problem. Okay. So where's the Lorax come in? Anyone know? This is a page from the Lorax from the '86 edition. It first came out in 1971. Anyone have a clue? Now's your chance. Chris?
I think the first edition referred to Lake Erie as a problematic ecosystem.
You got it. 1971. I hear things are just as bad up in Lake Erie. And then what happened is 2 research assistants from Ohio Sea Grant wrote to Dr. Seuss in the 80s, late 80s, and said, can you put this in past tense or something? And he took it out entirely without messing up his rhyme. And apparently it's the only Dr. Seuss book that he ever changed after it was published, if you believe what you read on the internet. So anyway, so thank you very much.
Let's start with a question from a student. Hold on. One of these students must have a brain. Maybe I'll leave it to Chris to ask the first question. Okay. Next time, guys, we're not expecting the students to ask the first question.
And I've also should say I acknowledged all my sources up here. There are a lot of them. So
I really enjoyed that talk. Very,
Thank you.
Good. And I could ask you a zillion questions, but
Yeah.
on the Gulf of Mexico, I thought it was very interesting. And clearly, that's being controlled by the hypoxic zone, dead zone is being controlled by the delivery of nutrients because of low nutrient yield. The
Right.
soil is very small.
right.
But what I thought was interesting that I hadn't noticed before is that that dead zone's gotten much bigger since the 1980s, but the nitrogen loading is level. But in contrast, the phosphorus levels of loading has gone up. And so I know you've done a lot of work on that you didn't talk about today about phosphorus
Yeah.
loading there. So what's your sense of currently the sensitivity and system to phosphorus, and why might that be different compared to Long Island Sound?
Good question. And I mean, that may support the idea of increased nitrogen sensitivity to the system. I'm not sure what I would say about the phosphorus. I mean, I argued for years that people should consider phosphorus down there because we could show definitive evidence of phosphorus limitation in the spring when most of the hypoxia develops. And we convinced Bob Howarth, who reviewed one of the papers, so if he believed it, I figure most people would. That said, you don't have a phosphorus problem unless you have a nitrogen problem. And it's because there's such an excess of nitrogen loading there that there's also phosphorus loading, but it doesn't keep up with the nitrogen loading. And we've seen, particularly in high flow years, 2000, 2001, the whole coastal area of Louisiana, the dissolved inorganic nitrogen to phosphorus ratios exceeded 200 and were sometimes several times higher. And later on, we did total nitrogen to phosphorus, and those ratios were even higher than the inorganic ones. But and I also seen concentrations of up to 120 micromolar nitrate coming out of the river. So it's extremely nitrate loaded, and perhaps it's getting more nitrogen sensitive. The issue about phosphorus going up, I mean, if there's more phosphorus coming down in the spring and you're relieving some of the phosphorus limitation, that could increase the hypoxia potentially. Yeah, that's a good point. So, Larry.
You implied that one of your locations that mussels were cleaning up the water, and that was,
Lake Erie.
that was leading to hypoxia or eutrophication. And my question is, so there's a lot of effort to put oysters and clams around our water bodies. Does that mean that we're going to have increased
Sure. No. That would be a big leap. And I don't think Lake Erie is very well understood in terms of the Dreissenid impacts. What it has done is taken out a lot of the phytoplankton. The water's much more clearer, and it's probably made the water more favorable to microcystis blooms in particular, because I'm not sure they would be taken out by the Dreissenids. And microcystis does very well with pretty low phosphorus concentrations and does not fix nitrogen. So it's good at scavenging low phosphorus level. So if you've eliminated the rest of the phytoplankton because of the mussels, or a bunch of them, it possibly would make it an opening for the microcystis. I'm not sure if that's the case. The other thing it does, or people have talked about, making, it removes the biomass to the benthos. And in shallow, very inshore waters, some of those nutrients might be more readily available in the water column, which could also produce the blooms. Now, how that relates to mussels and oysters in Long Island Sound, I don't think I don't think they're comparable examples.
One thing that students and maybe non-biologists don't appreciate is these are invasive species, the Dreissenids that Jim is talking about. They were introduced into the Great Lakes in the mid-'80s in ship ballast water from the Baltic, and so they're not indigenous, and they cause major system changes.
They're not indigenous.
Yeah, but the boats were, ships were traced back. Yeah, so these are not native to Great Lakes, but
And they've really upended the food webs in the Great Lakes.
and the
So,
upper Hudson as well.
Yeah.
They clarified the upper
yeah.
Hudson.
And they're all the way to the West Coast now. So probably not a good comparison. But more questions? Kamazima? You can.
So you ended up with the tentative conclusion that the Long Island Sound is improving.
Yeah.
At the same time, from what you said, kind of worries me, because if phosphorus is an issue, and Lee Suter's work, Gordon's student, showed that phosphorus has an increasing trend in Long Island Sound, and that we might go back and play the same kind of song Lake Erie is playing right now.
I don't see phosphorus at present as being a limiting nutrient anywhere in the main stem of the Sound. There's not as much data as I'd like to see. But I can imagine in certain embayments, if there's a large amount of nitrogen coming in groundwater or something very localized, you could get phosphorus limitation. I mean, if you continue to reduce nitrogen, some people make the argument sometimes, well, you keep reducing nitrogen, then phosphorus is going to become an issue. That's not the case, because what happens is if nitrogen is the limiting nutrient, you reduce it more, it's even more limiting. So phosphorus is less important, actually. So I do think it's important to maintain measurements of both. Like I said, if you read the EPA National Coastal Assessment, their summary of what the major nutrient problem in the Northeast coastal waters is, it says phosphorus. But that's because their thresholds are way too low. So I think you've got to keep studying phosphorus and monitoring phosphorus. I don't see it becoming an issue in Long Island Sound anytime soon. So.
Organic nitrogen. So a lot of about legacy.
Yeah, well.
A lot of organic N is coming.
Right. Well, there's legacy N and P, clearly. And, of course, you get P release if you get more hypoxia and anoxia. It kicks out phosphorus, but also ammonia in some cases. So, the legacy issue is a huge problem that we don't have a good handle on. So, other questions? I know you want to all get to the barbecue. So.
Well, if there are no further questions, let's thank our speaker one more time.
Let me say one thing. Part of the reason I'm here is to preach for Long Island Sound. So if anyone wants to know more about Long Island Sound, there are lots of other issues in Long Island Sound I didn't even touch today. So if you want more information, if you want to know how to do research there, if you can bring research money to Long Island Sound, all the better. So, feel free to ask me about that stuff. So that's my job. Thank you.
Just one more thing. If you're headed out to the barbecue, we need chairs. So if you're headed out that way, you can bring a chair.
Yeah, so nitrogen's been, phosphorus is going up in that graph, yeah. Yeah.
Better than the nitrogen.
Well, actually, if you do the models, well, it'll be.
Well, have a jolly good time.
Sorry.
Mathematically, well, the spring, particularly high flow years, when the phosphorus, when the hypoxia is growing, that's when it's phosphorus.
Very interesting.
They don't fall over, and then they, and then you get one table.
Yeah.
Same period, it's been going up. Since 1998, it's been going
Yeah.
up. Maybe that, and we've only just figured out that it's cyanobacteria, so.
Okay. Well, obviously, yeah, in Lake Erie, that could be a problem. In the
Yeah.
Gulf, you don't get
The
cyanide.
cyanobacteria,
No.
yeah.
Well, you get some marine ones, but
Yeah.
some coccus because of yeah, but in Lake Erie, which again is, it's agriculture is a major, Lake Erie is a miniature organism next to it. So.
I actually studied in soil ecosystems, not water
Right.
ecosystems, I don't know that much about soil.
Yeah. Well, then.
But that the studies that just show that it actually promotes growth in maybe
Well,
you're all.
because that's nice, but because cyanos are just heterotrophic bacteria with photosynthesis, basically.
Well, that's the thing. If the organism uses the Schick-Monte process, then glyphosate will kill it.
Okay.
And if it doesn't, then it's fine. It's like you would spray it on your unit, just
Right.
like it often cares. But if you're photosynthesizing at all, then
Right.
it will kill you. And so that's why the cyanomes that are
Yeah.
so
Best
way to
love this.
get it
Because,
easier to-
no, it's killing all the bacteria.
Right.
And it's opening up the unit essentially
Right.
for the cyanomes. That's what I'm learning when I'm not testing.
Yeah.
Interesting thought.
Stack them up in six.
Yeah.
Okay. Okay.
Glyphosate and some of those other things have numerous unknown effects.
So it's no safer to say.
And a lot of those are organophosphates. So
Yeah.
organophosphate in them.
Actually, yeah, it's on top of everything.
Yeah.
It's on top of the P that it adds into the
Right.
system. The way that it changes the topologies where it goes, including, gut windows,
Yeah.
because some of your guts use, vision. Anyway, thank you for a very interesting talk.
Sure.
Yeah,
Okay.
six states.
Your talk was loaded.
Yeah, I already took out my.
Oh, you did?
It's on the top of the computer. You can get rid of it.
There. Very good.
Good more parts? Yeah, they gotta come back. Okay.
Yeah, I think it's fine.
Oh, it's out there? Yeah, let's bring that. Yeah, otherwise it's... Enough for that. Yeah, no, the six is okay, but
It's awkward.
there's a technique to doing it.
Yeah.
Are you pushing or pulling? No, Mark's speaking. Okay.
Maybe, just give it the door.
Where are we? Yeah. Okay, I gotta move all these chairs out.